going to cover up here. And then the very first thing, as a beginner, since this is our very first session with IoT hardwares, so that is why I'm more concerned about giving you the basic criteria. First of all, the basic criteria means understanding how you can start with IoT, what special kind of hardwares or software requirements you may have as a beginner, and what are the concepts behind that you may need to understand while starting with. So IoT, the concept, the very first thing it describes is a network of physical things. And these things here can be anything that you see around, whether it is a chair in your room, a table, even if it is like your kitchen appliances, your TV, your smartphone, all those things that you have access to in your day-to-day life, they come as physical objects or things right here. And when we connect them together with the purpose of sharing or exchanging data to achieve certain kind of application, then it becomes IoT, that is Internet of Things. Connecting things to internet for exchanging some kind of data becomes your Internet of Things. And these devices, if we just take about the stats that we have from this IoT world, it is said that around 7 billion connected IoT devices were reported in year 2017. So you can imagine how things are changing over the years. And it is expected that by 2025, the count may be even 22 billion. So in coming year, we may see like 22 billion devices connected together, and continuously they are transferring some kind of information. They are exchanging data, and they are making our applications useful for the end users on the other side. With these IoT systems, we talk about internet connectivity with various types of standard devices, including computer, mobile, tablet, and even any kind of dumb devices like your toaster at home, even your heating appliances or cooling appliances, all those things, if they can be connected to the internet, they becomes a part of IoT. And this virtual setup of smart things basically helps us to improve almost every aspect of life, because we are able to communicate with things around us. We can control them from anywhere in the world. Just imagine like you are at office, and you from there itself you can check in whatever things are stored in your refrigerator, so that while returning from office to home, you can buy the additional things that you may need for cooking today. So that is how easy these things are going to make your life. There are even some smart refrigerators that can send you the list of items that is stored inside just with your single ping to that IP address of your refrigerator. This is a level of advancement we can see, and these things are making our life definitely much easier with time. These IoT based systems can be also used in critical care instances, like for patient care, for monitoring patient health from any distant place. They can also work for animal tracking, etc. So these applications are widespread with the concept of IoT. And this technology provides us ability to enhance human to human, human to computer, and machine to computer interface by all means, because we are able to interconnect over the cloud, and we can send information securely over the cloud. If the network is established carefully, we can indeed access it from anywhere in the world, and this makes your IoT a sustainable choice in almost every application, including industrial activities, environmental, health, or transport activities. It can be used for smart city applications. We can consider it for home automation or even electronic devices, and wearables also contain the IoT concept within. This concept of IoT, if you just Google about when this IoT term was coined in, the name was obsolete till 1999. But it doesn't mean that the concept was not there. The name IoT was given by a CEO of a company during a presentation out there. That was Kevin Eston, who gave the IoT term, Internet of Things term, in 1999. But before that, there were several inventions that were working on the similar kind of aspect, whether they were based on the RFID networks or different kind of sensors and actuator combinations. So they were trying to set up, like the first invention that was there is Coca-Cola machine. And this was a very interesting concept where the local programmers designed things in such a manner that people or the customers in the city could check over internet to get an idea about whether there is a drink available in the refrigerator or not. So accordingly, they can come from their home to buy a drink from that vending machine. So this was an interesting concept, designed several years ago before the actual IoT term was organized. And there were many such inventions, like you started with that vending machine, then they designed a smart toaster also, and then came the term IoT in 1999. And after that, you can see several things came up into our world, including the smart refrigerator, smart watch, then the smart cars are also coming into the market these days. Google Lens, we have Echo and Tesla Autopilot. These are the further inventions we have with the IoT. And at present, you will see this concept almost in every part of your life. Wherever you go, some influence of IoT you will always find there. Now we talk about the components that are essential for setting up a IoT network. It basically starts from the sensors or the actuators, we can call them. We also have gateways and networks that are essential to send your data to the cloud platform. Then there should be a cloud management service layer where we are able to store data and access data at any time. And ultimately, there should be an application layer. So they, in combination, form your IoT architecture, and in layer by layer connectivity, they enhance your data transfer from one end to other, starting from sensors to actuators, to ensure some decision making in the field environment. So while working on these concepts, there are several types of hardwares that you will come across. And since in our coming 2 days sessions also, we'll be building up some hardwares from the scratch, considering this IoT concept. So before we start building any project in coming sessions, I'll first introduce you with the different types of hardware that as a beginner you may need to understand about. The first set we have is with sensors and actuators. What they are as a beginner, what you need to know about them, and what type of sensor generally you can have as a beginner when you start. So these sensors are the so-called things in your network. In IoT, these sensors make up your things part, and their main purpose is always to collect data from the surrounding environment. And at the same time, when we have to deliver data to the surrounding environment, the task is performed by actuators. So your sensors are a kind of input devices, and actuators are a kind of output devices. And they are required to be some uniquely identifiable devices that may have their unique IP addresses, so that we can communicate to them via a large network. Since we are already talking about massive network strength in IoT systems, so there might be like hundreds of devices connected within a single network to achieve certain kind of application. And in that case, when we need to gather information from a specific sensor, it should be identifiable on the network. And to do that, there are different networking structures that we may follow, and we may provide IP addresses to the devices also. or there are different types of communication protocols that can be followed to set up the network with these. With these IoT sensor networks, the prime concept is to collect real-time data. Whether you consider a kind of environmental application, agriculture application, or maybe some industrial application, the main purpose of having a IoT sensor network is to ensure that you are able to visualize real-time data on the cloud platform. And for this, we can use a variety of sensors, including gas sensors, water quality sensors, or moisture sensors are there, refrigerators, street lightings we can have, or you can have automobiles, production gear, we have rehabilitation equipments. All of them may require your network connectivity to send data to the internet. And these sensors can be even connected through wired or wireless network, depending upon what kind of sensors you have purchased or what type of application you are trying to build. There can be wired or wireless sensor. For instance, maybe you are working on a physical world application where sensors can be deployed easily with wires, like maybe a plant health monitoring you want to do, or maybe environmental health monitoring, room health monitoring you want to do, and you can put up some wired sensor over there. But maybe in other case, you want to track maybe patient health, and some invasive or non-invasive technology you may have to use to monitor regular changes in their body, or their blood pressure or heartbeat, or maybe some pacemaker kind of things you might have heard about. There are some advanced version of pacemakers whose frequencies can be adjusted from the outside directly by the doctors without doing the procedure again on the body. So these kind of things can be wireless devices. They can be connected from the cloud network with the secured passwords, etc. And then they can be adjusted on the network to transmit relevant kind of signal. With these IoT sensors and actuators, we are able to set up a complete network. You can consider it something like, with the IoT sensors, we are gathering information, but when we have to make certain decision in that target field environment, you need actuator. Considering a basic application, like you have environmental control in your room, in your conference hall, wherever you are sitting right now, if you want to put environmental control over there, you can put up some sensors that can measure temperature, humidity, or gases, etc. within that premises to ensure good air or bad air quality. And then based on that data, maybe you want to turn on air purifiers, or maybe fan or AC. So those will be your actuators, things that are translating signals into the physical movement. That becomes your actuators. So while working on this, you have input gathered from the sensors, and there is an actuator such as cooling fan that is going to make your final movement in that premises. And there has to be a controller as an intermediator that is going to make decision. And this plays the most important role on your hardware setup. If you are just gathering some data from the field environment and you are not able to make any decision based on that, it will not be of relevance for you. Rather, we need a continuous threshold analysis so that we can decide when to turn on fan or off, and that too automatically. We need not to interfere in that process. Based on this, you will find these sensors and actuators in almost every area, as you can see, in logistics, healthcare, travel, retail, or automotive applications. Everywhere you will find these kind of things. And these sensors again can be of different types, like analog sensors and digital sensors. Getting better in terms of these analog and digital sensors, in layman language, you can consider like a sensor that can give you a continuous range of output or decimal point output. That becomes your analog sensor. On the other side, Digital sensors will give you outcome in the form of zeros and ones. There are plenty of sensors that only give you input in the form of 0 and 1. And there are sensors that work on both these cases as well. They can be used as analog sensors as well as digital sensors, depending upon the requirement, since they have both capabilities on the same chip. And while making connections for these sensors, again, you have different types of interfaces that you can use. For instance, if I quickly show you different types of sensors that you can access while working on your hardware design mechanism, let me just quickly switch to a camera over here. Okay, so I'm showing you the secondary screen also side by side. And for instance, there are plenty of sensors that you can find, starting with this one basic sensor I'm putting up here. This is a kind of gas sensor. You can see the details here are written as MQ7. That may not be clearly visible due to the camera resolution over here, but yes, this is a kind of gas sensor. This upper part, this shows you along with a net connected on the top that will pass air inside this chamber, and then it will do analysis inside regarding what quality of air we have, and accordingly it will measure things. So this is a kind of MQ series sensor. And there are unlimited sensors from the MQ series itself. For instance, this itself is a simple MQ7 sensor. Similarly, you will find sensors like MQ2, MQ4, MQ5, MQ6, MQ135, MQ121. These are different ranges. And depending upon what kind of application you want to achieve, there may be different options. Like this particular sensor may be measuring carbon monoxide. You can consider 135 MQ135 that measures CO2, carbon dioxide. Similarly, some of these sensors measure alcohol. Few of them measure methane gas. They're all gas sensors with ability to measure different types of gases. Along with this, for instance, I can show you this one. This is a DHT sensor. We call it a simple temperature and humidity sensor. And there are so many manufacturers that design this particular sensor. This is a very basic sensor you will find in the market. And these sensors basically have their own specification ranges. For instance, when I'm keeping these two sensors over here, the decision to use any of these sensors completely depends on what kind of specifications you have in your network. For instance, in my network, I need a temperature measurement between 10 degree to 50 degree. You have to find a sensor that measures within that range, because there are like hundreds or thousands of different temperature sensors designed by different kind of manufacturers with unique specifications. Some of them are able to measure maybe in the negative temperature range also. Some of them can work only on the positive temperature range. They will have always the operating specifications, and accordingly you may have to deploy them. Similarly, these gas sensors also, they will have their own measurement range depending upon what range of gas influence you have in that particular area. Like if you are putting it in some industrial setups where continuously some work on chemicals are going on, and so many types of harmful gases are being released, so in those areas you may need gas sensors with very wide range of measurement ability. But maybe if you are using it for a residential measurement where there will not be like very major fluctuations in the gas sensing, and minute range will also work, in that case maybe these MQ7 sensors will also work. Similarly, we have like this one sensor I can add up here. This is a simple water sensor. It is also written here as well as a water sensor. And the sensors that I'm showing you here right now, they are very basic sensors. We can also call them like demo sensors. When you start with IoT projects, you can start with these mini sensors. They are beginner friendly sensors. You can see like they are plug and play type sensors. They have simple pins here on one side of the chip. Here also you will see some pins are there. And beside these pins at this position, the pin information is always written. So as a beginner, whenever you want to start, the description about these pins you will find here. And along with that, you will also get manufacturer specifications regarding how to use these sensors. For instance, for this DHT11 sensor, if you look for a data sheet, several manufacturers will provide a data sheet for this, because this is a very basic sensor designed by same principle by different manufacturers. Just they make material variations depending upon what range they have to measure for temperature and humidity. So by looking at manufacturer specifications simply, you can decide which one of these you may need to use. For instance, for this DHT range, you will have DHT11, DHT22. These are most commonly used. This DHT11 has smaller range, whereas DHT22 has a wider range. So accordingly, you can pick up. Other than this, the different manufacturers also offer SHT series. For SHT series also, you will find like SHT21, SHT22. These are the commonly available series. And they again have different abilities. There are some BME range sensors also. They also provide temperature, humidity, and pressure like measurements. Similarly, here I can add one more sensor. This simple soil sensor. In some of the project that I'll be demonstrating in coming days, I'll be using many of these sensors, and there you will learn how these tiny chips we accommodate into a IoT sensor network, and from these chips, how we send data to a system online, and then how we can analyze that data further. That we will learn step by step. But this is a simple soil sensor. We connect a reader module with it from these pins, and this particular chip we insert into a soil pot, and it will help you to measure soil health, the moisture level within the soil instantly. Again, this is a simple demo sensor, so you cannot expect so much accuracy from these kind of sensors. But yes, to start with, these are good options. This one also, since this is a water level sensor, you insert this into a water mug or in a glass for testing purpose, and then you can observe how it reads all the water levels in this range. When water is at this level, the output will be different, and as it grows, the water will be different. So you might have heard that sometimes students design projects like rain alarm or water tank alarm, the filling alarm for the water tank. So that is based on these sensor concepts. We put it at certain level, and when that certain level of threshold is met on the network, accordingly it may send signal to the controller, and then controller can ring a buzzer or maybe turn on a LED light or maybe some indicator accordingly. So that based on requirement we can do. Here we have one more sensor. This is your LDR sensor. There is a LDR on the top of this position, and then we have a potentiometer here. This blue one you can see, this is a potentiometer, and this side we have some pins that we can connect with the circuit to get readings from this LDR sensor. And the simple purpose of this LDR sensor is this is a light dependent resistor. It will sense brightness or darkness levels around. And where you can link the concept of this, like automatic street lights you have somewhere, they may be based on LDR concept. So what this LDR will do, it will keep on sensing if there is sunlight, then it will keep that street light off. As soon as it senses darkness outside, it will turn on the street light automatically. So this simple chip can do that task. Now I'll add up one more sensor in the sequence, this one, a very important sensor. Can anyone identify this sensor? I will also look forward for interactions in the chat box. If anyone can identify this sensor, because this is very commonly used in different types of projects that students make. It is good to have interactions in the chat box as well. Let me know if any of you have identified this sensor. Or if you cannot identify, then also let me know in the chat box. Can I expect some interactions in the chat box? Okay, no problem. You can just respond me in the chat box. If you don't know, definitely that is why I'm here. I'm going to describe anything and everything that you have on this hardware part. This is a IR sensor, infrared sensor basically. You will find one transmitter and one receiver LED on the top of this. It will send signal. One of these transmitter LEDs will send brightness signals, infrared signals we call it technically. And when that signal gets obstructed by something ahead of it, the receiver LED will calculate the distance of that object or information about that object, that whether there is a free space ahead or there is object ahead, and accordingly it will help your controller to make certain decision. And one most common application you will find for this is in simple robots that we design. Sometime you might have heard your graduation students designing line follow robots or path following robots. They also use these IR sensors, very popularly used sensors in the simple projects. And they can be also used in car parking system projects, because they will help you to sense whether there is a vehicle moving in front of the sensor or not, and accordingly the car parking system counter you can make work. So these sensors can help you to get measurement. For instance, this gas sensor, this one contains both A0 and D0 pins. It is written on the chip here. If you find this kind of chip anytime, anywhere, it will be written like 4 pins are there. One is VCC, one is ground, then is a D0 pin, and then is a A0 pin. So when it is written, it is very easy to connect. The VCC you have to connect with the power supply, the ground you have to connect with the common ground, and then D0 and A0, they are optional. When you want to read a digital data from this sensor, you can connect it on D0. When you want to connect over analog channel, you can use A0 line. Similarly, this sensor, there are only 3 pins, and it is written as data on the middle pin. The side one is VCC, the last one is ground. So accordingly, VCC and ground first you will connect, and then this data pin, the middle one, you will connect. It can be connected on the digital port or analog port, and accordingly you can define that port in your coding, and it will be read from that particular sequence. These are some commonly available sensors in the market. On the similar note, if anyone is like from the electrical background or somewhere, these are some kind of commonly used voltage and current sensors. You can see this one and this one. This is a voltage sensor, and it can measure up to 240 volts. From any minimum range to 240 volts, it can measure directly. You can connect a main supply on this side of the chip, and on this side it will auto downsample that main supply to 5 volt signal, and that 5 volt you can further connect with your microcontroller, and it will translate your main supply to microcontroller to make exact decision about how much supply is coming from the system. You can use it like with solar systems to measure how much voltage is there, or there is a current sensor also. This one also you can use maybe with the solar systems. I have done many experiments on these systems also, like connecting it with a solar panel and seeing on the load that how much it is consuming and how much current is flowing in the network. These sensors can help you with that. So these kind of tiny chips you will find in the market easily, and depending upon the requirement, you can pick any of them to set up your project. And each one of them have different connectivity requirements. Some of them can be connected on the analog channel, some of them on the digital channel, some of them require transmit and receive pins to connect. And when I'm talking about this analog channel, digital channel, etc., this is basically specification of your microcontroller that I'm going to discuss further. So don't worry if you get confused with anything, everything we are going to solve further. So I'll just stop this one for instance, and we'll get back to the presentation for a while, and then I'll also show you the further hardware options. Okay, so we are at this position. Analog and digital sensors I have discussed with all of you. And furthermore, now we have the digital sensor. This one also we have discussed. Now I'll talk about the communication requirements with these. For instance, with the communication interfaces, the most commonly used one is your UART communication. The initial two options I have given you, the analog and digital sensors. After that, the third option you have is UART communication. TXD and RXT lines, if your sensor defines this preferably on the chip itself. As I told you that on all the sensors, on the pins itself, it will be written that how you can connect it with the microcontroller on the other side. So when it is written as A0, D0 or analog digital like terms are written, means accordingly on the analog or digital channel you can connect. But when there is a sensor in which TXD and RXT is written, so accordingly you have to find TXT and RXT pins on the microcontroller and then you can connect them. I'll show these type of sensors also to you in the coming applications. Similarly, we can have SPI interface, serial peripheral interface. And for this, the pin names will be something like this: serial clock, master output, slave input, master input, slave output, and slave select. These are the SPI interface, means they require 4 pins to communicate. And these pins may be required to transfer data from the sensors to the controller, as well as any acknowledgements or any signals that they have to exchange as a slave and master with each other. So that can be done with this SPI interface. Similarly, we have I2C interface. That is your inter-integrated circuit with serial data and serial clock line. This requires only 2 pins. One will be transmitting all the clock signals and the control information, and other will be sending the serial data for any kind of exchange in data or any kind of field measurements that we have to transfer. For that, these 2 pins can be used. These pins you will again find on the microcontrollers. Most preferably, these 2 types of pins are available on almost all kinds of basic microcontrollers. But these pins you may need to find based on the specifications of the microcontroller. If they are available, then only you will be able to make these kind of interfaces. Otherwise, you may need to pick one high-end microcontrollers accordingly. So this completes your sensor communication part. And now we will switch to the microcontrollers. And in these microcontrollers, again, we have a very huge list, same as sensors. I could show you a few, depending upon the limit of the section that we have. I'll also try to describe a few of the most important microcontrollers to you. If you want to start as a beginner in this area, what you can start with is Arduino, the most basic microcontroller that you will have. With this Arduino development board, you will have different types of communications possible. It can be analog channel based, digital channel based, or transmit receive, SDA lines, SPI communication. Everything is possible on the Arduino board. And the specific thing you need to know about it is the Arduino boards are currently available in so many forms in the market. You can pick any of them based on your requirement. Few of them have only basic capabilities, few of them are very advanced in nature. So accordingly, you can pick up a device and you can start working on any project. The newly designed Arduino boards are even coming with the Wi-Fi facilities or Bluetooth facilities. The traditional micro Arduino boards that students are using from past several years, they come with only basic interface. They can communicate with the sensors and actuators only. They cannot communicate with the cloud directly. So these are just few options. Other than this, also you will find several different types of Arduino boards that can be used, and you can pick any of them. The price will accordingly change, the configurations will accordingly change, the chip type and the memory, etc., everything will vary accordingly. Among all these, the most common solution you have is Arduino Uno. If any of you is planning to start with IoT for the first time, you can start with Arduino Uno, because this is the most basic one to interface, easy to code, and easy to deploy in the field environment. And there are plenty of pin options that can help you to connect a wide range of sensors easily. For instance, on this pin diagram itself, you can identify all the essential ports that you may need. The best part of Arduino is that this is an open source platform, and you can find plenty of information about this Arduino platform on its official website as well as on the forums that they have designed. Since a huge amount of information exchange always keeps on going on the Arduino forum, and it is easier for beginners to ask queries and get answers from there. For the programming part of this Arduino, there is a dedicated software that we call Arduino IDE, Integrated Development Environment. I'll show that software also to all of you so that you can get an idea how we start with programming of this Arduino. Starting with the basics, on this chip, you have all these different types of controls. There are some power supply section. On the top of this board, you will find power supply section, reset buttons. And here you can connect your USB cable that can be further attached to your laptop or computer for transferring code or software to this particular board. Similarly, we have a voltage regulator over here. We have a adapter port over here that you can connect with a dedicated 7 to 12 volt adapter you can use directly to power up this particular chip. This is your main microcontroller board, and this Uno consists of Atmega 328 microcontroller IC. And you can see this is a detachable IC. You can take it out if it stops working, and you can insert another IC. So that is another benefit you will have with this. And then comes the remaining pins. Here you can see these are analog pins. So we call it a analog channel. Analog channel means when you can share information with the analog sensors on the other side. And this basically is a input type port only. Analog port is an input type port only by default. So it will always take input from the sensors and it cannot communicate outside. This side we have digital port. All these pins, they come under digital port. However, the pins here have multidisciplinary function. Some of them can act as SPI interface that we recently discussed about. The starting 2 pins are used for the transmit and receive with UART communication ability. Then on the top of this, you will also have I2C communication facility, SCL and SDA lines. So all these are integrated on the digital port. So we define it simply as analog port, and this we define as digital port, and this particular portion we call as power port. because here you will find all the power supply connection like 3.3 volt, 5 volt or ground, etc. Whenever you have to power up external sensors or actuators with Arduino, you will use this port, and there are 5 volt and 3.3 volt to do the same. I have recently shown you sensors, and I told you that on sensors it is generally written that they have VCC, ground, and A0 or maybe D0 pins. Something like this will be written on the sensors itself. So VCC pin from here. First, you will check the specification of sensor, whether the sensor works on 3.3 volt or 5 volt. Accordingly, you will connect the VCC with any of these two pins. Similarly, the ground will be connected with the common ground that is available right here. Generally, your Arduino comes with three ground pins, three different ground pins. At this position, the new age Arduinos have two grounds, and one ground you will find in this side in new chips that are designed. So three common grounds you always find on the chip, and accordingly you can expand your connections further. Then comes the A0 and D0 wire. So DA0, whenever you have to make a communication with the analog channel, here you can connect it with any of the pins. Similarly, if you want to do digital communication, you can connect it on digital port on any of the pins. Anywhere it can be connected easily. So I have given you a quick description about different types of analog and digital ports now. The number of pins on the digital side are 14, and on the analog side there are 6 pins. And there is one more interesting fact you need to know. On the digital pins, if you observe it very carefully, few of the pins have a waveform in front of them. These pins, there are 6 such pins. The remaining pins do not have this waveform like signal. This is a signal appearing like this, a waveform like signal appearing in front of the pin number. This indicates a PWM signal. And what is the purpose of this? I already told you that analog port by default is an input port. It is written here analog in. And the digital port can work as an input and as an output as well. For instance, you have an application where you need to send something outward from the controller. Like you need to turn on light, LED, buzzer, or maybe any appliance on the output of this, maybe relay, etc. So you may need to send some signal outside. That is possible with the digital port. But again, there is one thing you need to remember. There can be digital or analog devices that you want to connect as an output over there. So when you have to connect digital devices, any of these pins you can use easily. But when you have to connect an analog device, you specifically need to use the PWM enabled pins. Only these pins you can use because they only have ability to translate your analog signal on the output side. Because analog signals definitely have a varying range of quantity. So that can be measured by these PWM pins only. So for instance, if someone gives you a task like you have to uh, work on the brightness levels of a LED. That is one task. And second task is you have to turn an LED on and off. These are two different things. When I talk about on and off, LED is first an output device. When I ask you to do on and off, that means a digital operation. So you can use any of the pins from the digital world. But when I talk about brightness level change on your LED, like I need a dimming effect on the LED. So that you can do with the PWM pins only, because that only can translate your brightness levels into different thresholds. So this is how different pins may help you to make different decisions. Similarly, the power section, from here you can use on the actual board. And if you want to just see this board in actual, that what versions of this you will find in the market, let me just quickly show you what options you will find for this. For instance, I have here two different types of Arduino Uno. One is this chip, and one more that I can show you, this chip. These are two commonly available Arduino Uno board. As a beginner, when you start your project, it gets complicated that which one you should buy, because there will be little bit difference in both of these. The image that I have shown you is from this one. This one I have shown you with a longer chip. This one I have shown you, and it comes with the official logo from Arduino. Generally, it will come with this one. So when we have this kind of chip, this long IC available as brain or CPU of your this microcontroller, the biggest benefit of this is that while working, if you end up damaging your main CPU, you can just take this IC out and you can replace it within just 20-40 rupees. That will be an easier option to get your chip to work again without requiring to buy entire chip. However, in this case, the second case, this chip is completely fabricated on as a scare over here, and this is SMD component soldered by a machine directly. This is also Arduino Uno. The pin descriptions are same for both of these. Everything you will find same, but the chip is the main difference. Now, in this case, if you end up burning your CPU, you will not be able to replace it yourself. Either you may have to go to some company to get it soldered again as a different chip, or the only option you have is you need to buy this entire chip again. So while buying these two, when you go to a local vendor, they will always show you this one as first option, because this one is available at a low price. And of course, they also have more margin on this, so they try to sell this one first. This one, because this is an authenticated chip from Arduino, little bit expensive. A general price comparison, if you will do, is this may be available within 300 to 350 rupees, and this one may be available between 700 to 750 rupees. Almost twice price difference you will find in these. I will always suggest you to buy the good one, because this is a long lasting solution for your work. And if your students are also working, suggest them to buy this one, because there is one more issue that you may face with these chips. It is not just about this CPU, but at the same time, this chip, this low quality one, this doesn't come with drivers by default. So when you start working on the hardware for the first time, it will ask you to install drivers manually. And for beginners, that gets little bit difficult. You may need to find them online. They should be compatible one, and then you may have to install them manually. With this chip, the good quality one, it comes with auto installed drivers. So as soon as you connect the wire with your system, it will detect the chip and it will start working with the software automatically. So that is also going to save much of your time. And with this chip, because drivers are not installed automatically, so if you are working like on lab equipments, on lab systems you are working, and every day you might be connecting on a new PC over there. So every time you may have to install drivers on the new system. Sometime maybe you are working on your laptop, sometime on the lab computer. So everywhere you may need to install those drivers. But with this, you can connect it anywhere, everywhere, and it will never ask you about any additional formalities. So this is a quick to run a chip that you can use as a microcontroller. Now you can see that here I have connected a wire. These two ports, as I have shown you in the diagram also, they are for your power connection. Someone has commented that there is no voice. Can anyone else please let me know if they are getting voice or not?
Yes, ma'am. Voice is clear.
Working fine, man.
Okay, thank you so much. So we have these two ports for this purpose. And similarly, you will see these black ports this side. In case if you don't want to connect through these ports, you can use a adapter right here. And that adapter is something like, you might remember your Nokia phones in the beginning, the keypad ones. With them, we used to have a round pin charger. So that kind of adapter basically works with it. You can see that round clip over here, same as your old mobile phones. So you will find easily some 9 volt or 12 volt adapter in the market that you can use on this. Although the chip, both these chips or majority of the Arduinos, they work on 5 volt, but there is automatically available a regulator on the chip. They have a 5 volt regulator. So we do not connect a 5 volt adapter from outside, because that will not serve the purpose on the chip, because regulator will not get enough supply from the outside in that case. So we always recommend to use a adapter with more than 5 volt, and the best one recommended is 9 volt or 12 volt adapter, so that the 5 volt regulator can automatically lower down the supply, and then it will serve to the all ports available on the chip. At the same point, here you will find a red color reset button. This one you can see a reset button. Here also you will find a reset button. So this is for a quick reset on your hardware. It will not erase the program that you have inserted on this chip. Just to refresh your software and hardware connections, we press this reset button. So anytime if like you are designing a hardware and some expert who is telling you about all the connections, if they ask you to press a reset button, this red button is basically that they ask you to press, and it will not make any software change on your chip, but it will just refresh everything, and everything will start working from the scratch automatically within a few seconds. You just press it and release it, nothing else. So these are your basic Arduino Uno chip. And then I'll show you one more that is a higher level to this. We call it Arduino Mega. Arduino Mega chip, it is a little bit advanced in comparison to Arduino Uno. You can see first the chip size is increased, the number of ports are increased, the number of pins are higher, and at the same time the memory capacity is also more. So when your project is not handled by the mini chip that is your Arduino Uno, you can extend your microcontroller with this one. It has all similar kind of functionalities. You will find analog port, you will find digital ports, but the pin number is more now. For instance, in case of your Arduino Uno, you were having 6 analog pins. If it is not possible to connect all your sensors in those 6 pins for the analog channel, maybe you can extend to this one, because it contains 2 analog ports from here to here. So 6 pins here, 6 pins here. So you can extend it further. It has 16 analog pins basically, extended from 6 to 16. So great hike you will find. Similarly, the digital pins are in this section also, dual portion of digital pins you will find. Here also 2 ports of digital pins you will find. And you will also observe one thing in this Arduino Mega board, that they provide multiple transmitter and receiver pins. Here in this side, they have multiple transmitter and receiver pins. So again, if your Arduino Uno, because there we have only one transmitter and receiver, as I told you, on pin 0 and 1. But if you need more lines for this, you can use it from here. There are multiple transmit and receive pins available. And similarly, the SDA and SCL channels, they are also available in multiple forms, like 2-3 different SDA, SPI channels, etc. are available. So in this way, your structure of your network, your sensor, actuator connections can be expanded to any further level. These are your basic Arduinos that I could show you instantly over here. And furthermore, we'll talk about few more setups that we can use for this purpose, including your Raspberry Pi board, that is also very much popular, and ESP board. They both are popularly used as a microcontroller as well as gateway. In both forms, you can use them. For instance, coming to this ESP32 first, ESP32 room chip you will find. Note that this ESP chip again comes in so many forms. You will have ESP8266, you will have ESP32, ESP01 module, ESP02 module. Each one of them have their different capabilities, They are used for different operations. They can have different specifications, and your selection has to be very careful depending upon what project you are designing and what type of requirements you have with that project. For instance, I'm talking about ESP32 room chip over here, and it will be written right here. The type of ESP is always written on the chip itself. So while buying, you can see that whether it is ESP room or it is ESP8266 or any other. I'll show you a few options in the hardware also for this. And you can see that again, there are different types of pins. We have different analog pins again here, different digital pins again. The very first thing we need to understand about this ESP chip is this can also work as an independent microcontroller. If you are not able to achieve certain tasks with Arduino, you can use ESP32 as your Arduino as your microcontroller. The main difference between both of these is, in case of Arduino, if we talk about the base model, that is Uno, the pin numbers are more. In ESP32, pin numbers are less. But in the contrary, the memory in Arduino Uno is less, and in Arduino in ESP32, memory capacity is very huge in comparison to both of these. So when you are more concerned about higher number of pins but can sustain with lesser memory, maybe you can go with Arduino. When you need more memory and can maintain with the lesser number of pins, then again you can go with the ESP32. Similarly, there are few other things. When we are working on Arduino Uno, this is an independent microcontroller only. It doesn't have any kind of ability to send your data to the cloud directly. Rather, you will need help from an external chip. We call it gateway. In detail also, we'll discuss about that further. A gateway you will need to connect with Arduino Uno, and then that gateway will send your data to the cloud. But here on this ESP32, it is a combination of microcontroller plus gateway. So both things you will have here. So whether you want to collect data from the field environment and side by side you want to send it to the cloud, this ESP ROM will do the thing for you. And there is one more advanced feature. It comes with integrated Bluetooth or BLE features. So you get three things on the same chip. You can have two, or we can even call it three different type of gateways, because Bluetooth and BLE also have a set of different features. Although BLE is an extension of Bluetooth, but we can call them a different set of gateways. So three different types of gateways you have on the same chip, and it also works as a microcontroller. And in comparison to your Arduino, this is a low power, low cost chip. This one works on 3.3 volt. This entire chip preferably works on 3.3 volt. However, Arduino, as I told you, it works on 5 volt. So depending upon what are your requirements in the field environment, you can choose a chip. With this ESP32 room kit that I'm talking about, the few specifications I have listed over here. It provides you wireless connectivity that I told you. It supports 802.11b GN standards and operates on 2.4 gigahertz band with 150 Mbps capacity. And it can connect with any of your Wi-Fi available, like from your mobile or your central Wi-Fi system available in the premises, and then it can send data anywhere. Bluetooth low energy specifications work in dual mode for this. So easily you can transmit data, you can receive data on this. And there are LEDs also available on the chip that can indicate you that how your program is working or what communication is happening. These indicators are available on Arduino as well. So there are also some indicators you will find. We will see that tomorrow also when we'll be working on a project. On this ESP platform, you will have some boot buttons, enable buttons also. Same as I have shown you the reset button on Arduino Uno. Here you have two buttons. One is boot button and one is reset button. So boot button we sometimes need while loading program on the ESP board, and reset button is same as your Arduino. And the power options I have already discussed with you that it works on 3.3 volt preferably. They have a on-chip regulator for that. So again, you can use a adapter from outside that is greater than 5 volt, and accordingly it will step down that by using a internal 3.3 volt regulator. This is a common pin configuration you will have with ESP32 ROM. And here again, you can see that many of the pins are PWM enabled, and many of them can allow analog communication. Many of them have transmit and receive options. There are inbuilt RTC modules also. And we have these GPIO pins, means general purpose input output. So when we have to connect input and output, that means your sensors and actuators on any of these pins, we can connect them. And this one is your USB cable connection, USB type C, we can connect over here. And then we have this RST and boot buttons. This one you may need to press when uploading your program. This one you can use for the resetting of the chip anytime. There are multiple grounds, and there are multiple power supply pins also. 3.3 volt you will find this one right here, and accordingly the communication we can establish with this. Similarly, we have Raspberry Pi. The hardware I'll show once I discuss this Raspberry Pi, and different options also in this I'll show you. With Raspberry Pi, again, this is one high-end microcontroller you will have in the market in the IoT area. For the academic use, I must say. In case of industrial uses, you will find many advanced versions of the microcontrollers. There are advanced microcontrollers from Siemens, and many other companies are designing. They are very highly powerful. They can manage your big machineries that work on 440 volt directly. So accordingly, high-end microcontrollers also you will find. But for basic projects and for academic uses, for research uses, generally these controllers are used by people. So this Raspberry Pi is not just a microcontroller, rather this is a mini computer that can help you to even run a computer directly without a CPU. Even in my premises, I also use a Raspberry Pi as a CPU, and I run my TV or LCD from that directly without using any CPU for your LCD or for your monitor. And there are plenty of different versions of this Raspberry Pi you will find. Over the year, they are launching new version of Raspberry Pi. They are offering few advancements in terms of features, the abilities of the hardware, and accordingly, the connection abilities are improving over the years. Currently, the latest one they have is Raspberry Pi 5. That has potential features, and you can design several high-end AI-based projects also by using Raspberry Pi 5. The initial versions were limited to the IoT connectivity only, but the Raspberry 5 and the advanced versions are AI capable also. They can run your heavy image processing practicals as well. So these systems allow you to interface a television, monitor, mouse, keyboard, so that you can set up a full-fledged PC at low cost. Similarly, on this Raspberry Pi board, the main setup is generated through a SD card. It doesn't have its own memory to store your operating system. Raspberry Pi needs the operating system to work, and that operating system is stored in a SD card. And the space for that SD card is generally on the back side of this port. You will find it right below this section, not on the front side, rather on the back side of this chip. You will find the SD card port. And this SD card can store, there are several different versions of the operating system also. You will find it from Debian, from Raspberry Pi itself. This is a Linux type operating system. And indeed, it can help you to create a complete virtual environment for setting up your different types of hardwares, and you can start communication through it. This Raspberry Pi system allow you to connect many different hardwares. That includes your HDMI port directly from here, means you can connect a projector directly, or you can connect your big LCD screen or a TV screen directly by using HDMI port. Similarly, you have CSI camera operator over here. This can help you to connect a CSI camera. You can even connect a webcam by using the USB port over here. There are 4 USB ports in this section, through which you can connect your keyboard. That is one essential thing you need to set up a computer. Then you can connect a mouse also. Similarly, you can connect your webcam through this, and even you have the audio port over here, this one. So when you have to do a video audio based operation, you have both options right here. There is a DSI display connector also. If you want to use this kind of display, that is also possible. There is a on-chip Wi-Fi and Bluetooth module again. So means this chip again can work as a gateway also, not just a microcontroller, but as a gateway also for your IoT project. And this side, here we have 40 GPIO pins. GPIO, I already told you, general purpose input and output pins that allow you to make connections with the sensors and actuators outside to receive and send data as per the application requirement. So here also you have the same. So what you can observe from this chip, basically, that there are almost every possibility available within this chip. And this is like a credit card size of chip. The more advanced versions are even getting miniaturized while having all the functionalities on the same chip itself. At this point, you can connect your Ethernet directly, or it can connect through the Wi-Fi. There is no need to always connect the Ethernet also. Like if you want to work in the Wi-Fi network, that also you can connect and you can start working on it. And one more fruitful thing about this, even if you don't have a like monitor display unit that you can use directly to get access to your Raspberry Pi CPU, it is possible to connect it through a putty connection. By using a putty software, you can easily access this entire chip and its functionality remotely from your laptop directly. Only thing you have to make sure is your Raspberry Pi is connected on the same network as that of your laptop. Otherwise, you cannot connect your Raspberry Pi on the laptop directly because it doesn't have compatible port on the laptops. So they require you to connect either on the TV screen, display projector, or on your monitor, because that has direct HDMI port which is compatible with this Raspberry Pi. But those who want to connect it on the laptop, they can use wireless connection through the putty terminals. So that makes things easier for anyone who want to work on Raspberry Pi modules. And if you want to know more about the chips or the pins that we have on this, again, you will find different types of GPIO pins. You can see the SPI information is also possible. The UART communication is also possible. You can find I2C communication also, that is possible. Ground is there. 3.3 volt is also there, 5 volt is also there. So it is compensating everything from the previous two microcontroller versions and adding everything as an addition to your high-end system design. So this completes your microcontroller section, and I'll just give you a quick idea about how these appear on the hardware side. For instance, I'll first show you with the ESP32 module, how does it appear and in what form you will find it. For instance, currently I have it in these two forms. These are ESP chips. You will find them, they look identical, almost identical. Then I'll put up one more over here, a very minute chip. This can also work as an gateway unit for you. So in coming projects also, I'll be using some of these chips to design different types of cloud data transmissions. Starting with this first one, you can see on the back side here, it is written Lolin is the name written here. And this is basically ESP8266 module. We also call it a node MCU. This is also known as node MCU. And several people consider it an alternative to Arduino Uno and a separate gateway unit. Means this one is an independent gateway unit. It cannot work as an microcontroller. You can see this is a mini chip. So this is a Wi-Fi gateway unit, and we can interface it with this Arduino, and they in combination will work as your gateway and microcontroller together to collect your data from sensors and send it to the cloud. The pin description for this is generally written on the backside of the chip, but even if you don't get it from the backside, you will find it in the specifications of this chip particularly. It comes with 8 pins over here. This is mini ESP8266 chip right here. If you don't want to use these two separately, what people do is they pick up this node MCU 8266. So this contains plenty of analog and digital pins on the sides, along with the Wi-Fi capability. So you can easily send data to the internet from this. And then comes this ESP32 room. Although they have similar kind of functionalities, but still the specifications will be little bit different. And this one also comes with the Bluetooth capability, and accordingly you can make connections on these pins that are, again, some of them are analog enabled, some of them are digital enabled, and this can again work as an independent independent microcontroller and gateway unit for you. You can see this side we have a port where we can, this is type A port you can find, and here you can connect your wire directly, and on the other side of the wire either you can use an adapter to connect it with the main supply, or use your USB cable directly on your CPU or a laptop, and you can power up this directly from there. So these are the commonly available ESP based chips for you. Similarly, for the Raspberry Pi, although there are plenty of the versions, in terms of cost also, if you want to compare all these, this one is very cost effective. You will find it within 90 or 80, 90 or 100 rupees easily in the local markets. Similarly, this one you will find in, this is your Node MCU, ESP8266 module. You will find somewhere around 500, 600, or sometime in 400 also, depending upon from where you are buying it. And this ESP32, a little bit advanced, this one you will find in 800 around. That is general price range for this. Moving further from this, we have the most advanced unit, that is your Raspberry Pi. I currently have it with a heatsink on the top because this heatsink helped me to reduce the power dissipation on this, and it doesn't get heated up when we use it for several hours. Otherwise, sometimes the chip gets heated up. So I have used on the bottom side, I have used this plastic shield to make it safe to put anywhere on the floor. And similarly on the top side, I have installed a additional heatsink. You can see this is an additional attachment that I have added here, and this I have placed with the nuts and bolts on the side. And below this green one is your actual Raspberry Pi chip, and these are the ports that I was talking about. You can see 4 USB ports right here, and this side is your Ethernet port where you can connect your Ethernet cable directly. Similarly, this side we have all the pins, and even the fan of the heatsink I have connected right here on the 5 volt and ground. So when I turn on this system, this fan will start running automatically, and it helps to try this cooling this particular chip while working on it. Similarly, here you can see this place. This is containing a SD card right now, which stores the operating system for this particular chip to work. So we can take this SD card out, and then we can insert it again, and we can load operating system over here. That operating system is usually heavier one, so you need a good capacity memory card to work. We generally recommend a class 10 memory card to have good speed on the processor. At the same time, preferably you can go ahead with 16 GB, 32 GB, or higher than that memory card, because that is good enough to store your operating system while allowing you a good enough memory to store your programs or to work freely on the system itself. So this is currently, I have Raspberry Pi 3B Plus module in my hand. And other than this, although all of them will look similar, like Raspberry Pi 4 will also look like this, Raspberry Pi 5 will also look like this. But yes, there will be some functionality differences. There will be some improvements in terms of software compatibility, as well as their memory, etc., will be enhanced with the change in chip. So any of these you can use. If we talk in terms of pricing for this Raspberry Pi module, for instance, this Raspberry Pi 3B Plus module, a few years back, this was somewhere around 8,000 around, but at present, maybe this is reduced, like 5,500 or 6,000 you can find for this 3B module. Similarly, 4 and 5, they will be little costlier. For instance, the latest version that you have for Raspberry Pi 5, that may be 9,000 or 10,000 around. You may also need a dedicated adapter for this to work. You have a dedicated port for the adapter, type A port, and the Raspberry Pi 5 comes with type C port, and accordingly the adapter you may have to buy. The memory card you may have to buy additionally, and similarly the Ethernet cables you may have to buy additionally to work with it. You may also have to get a mouse and keyboard so that you can access its functionalities inside. And other than this, as per requirement, you can have your cameras or HDMI, etc. HDMI cable also you may have to buy, because that is the most essential thing when you have to connect it with the screen, any of the screens like TV or monitor, etc. So this completes your setup for the microcontrollers. Similarly, other versions also you will find, like Siemens IoT 4040, IoT 2050. These are the commonly used industrial setups for microcontrollers. But currently we are talking about the academic purposes or research purposes, where these commonly discussed microcontrollers, I have already told you, you can use any of them. And now slowly I'll move further with the gateways. Few of them I have already shown you. That is your ESP32 and Raspberry Pi, because both of them can work as gateway. But what are the technologies that you may need to know in this case? First, we have the Bluetooth and BLE. These are the most commonly used on the lower scale, we can say. The classic Bluetooth technology was designed for continuous data transmission because it offers a robust connection, and the data rates were very high, but at the same time, it was consuming more power. So you might have used Bluetooth lakhs of times in your life with your mobile phones or with your laptops, etc. Headphone speakers, etc. Everything these days is equipped with Bluetooth and communication ability. At the same time, the BLE technology is designed as an improvement to Bluetooth, because this is a Bluetooth low energy version. It consumes less power and can operate for longer period of time. So when power is an issue for you, when you have to save on power, and like there is a field operation where power supply is not easily available and you have to run it on battery for the long time, in that case you can go ahead with BLE, a low energy solution, and you may need not to change batteries time and again. With this BLE technology, you can also have better encryption options. It comes with encryption algorithm so that you can secure your data, and it can even allow you to transmit information up to 1 kilometer distance, depending upon what type of chip you are using. For instance, in market, you will find Bluetooth chips commonly available as HC04, HC05, HC06. These are commonly used modules, and each one of them have different functionalities. So you may first need to again check specifications that you want to use for running your gateway unit, and accordingly you can choose a chip. This HC05 module comes with full duplex mode, so you can transmit and receive data easily without any interruption over here. It works on a 9600 baud rate. This is a very important thing when we have a communication between different units, and especially on the transmit and receive lines. So I'll describe this again when we'll be doing a project as well, because there in the code itself we have to mention baud rate. Baud rate is, in simple term, basically bits per second. How fast transmission will occur between two chips, that will be defined with the baud rate. And this thing we have to define in the software itself while designing our code, so that it can guide us throughout the process easily. This is the chip that you will find in the market for HC05. And you can see this is a very simple chip, and there are multiple pins although on the chip itself, and they comes with like RXT, TXT, ground, VCC, the state selection, and AT modes. There are different things available on these chips, but most commonly you will need only 5 pins from this. Again, the process is simple. You need one ground, one VCC, and then one transmitter and receiver line. So accordingly you can communicate with this. One amazing thing about this Bluetooth chip is that although this is a very mini chip, you can see this can offer you UART based communication through your transmit and receive lines, UART based communication basically. And similarly, it works on the AT command also. This first pin allows you AT command based communication. If anyone has worked on communication modules earlier, or have learned about the communication system that we follow in GSM, etc., you might have heard about AT commands. These are very important commands that we set up for the interface between two communicating modules. So they are something like you send AT from one chip, the other chip responds with OK, and this shows that you get an acknowledgement from the other chip. Similarly, AT plus like maybe anything, any message you have to send, like I want to send a reset message. So you write AT plus RST, and on the other side, chip gets reset accordingly. This is like transmitting commands from one end, and the behavior will be controlled accordingly on the other end. So from microcontroller, these commands we can send, and accordingly we can set some behavior patterns on the Bluetooth chip, and it will behave accordingly when set up into the real-time environment. Similarly, the next amazing technology we have in the gateway section is your GSM module. You might have heard about GSM from past several years. This is one of the most popularly used gateway unit, whether in terms of your mobile phones you might have heard, or different types of networks that we have heard on the basis of GSM. This allows you a quick radio frequency based transreception module. It allows digital signal processing. Huge memory capacity comes with these GSM modules, and they work with radio frequencies specifically to send and receive data. These GSM modules are again available in so many forms. They can encode, decode signals, they can process signals, they can modulate or demodulate signals. Depending upon what kind of chip you have used on the hardware side, accordingly, the modulations or the frequencies it will select. For instance, in market, initially we were working on SIM800L module. This is the most initial module you will find in the GSM area. And with this SIM800L module, it allows you to send simple calls you can make from here. It can connect to the internet through GPRS, TCP/IP protocol. It can also allow you to send text messages directly. And this is a very mini chip you can find. A few pins you may have to solder on this side or on this side. Sometimes it comes with the soldered option already. This is an antenna that you may have to mount on the chip, and accordingly it will catch signal and it will start communication. With this 800L module, it supports quad band operation. That was the most interesting part of this. This tiny chip can work on GSM 850 band, EGSM 900 band, DCS 1800 band, as well as PCS 1900 band. So it means almost in majority of countries, this can work easily, irrespective of which network they are following or which quad band operation they are following. This can be connected to the respective network easily. And this can work with any 2G SIM. You may just need to insert a SIM inside this, and then you can connect on any of these networks available in that area, and you can support your message transfers, GPRS data transfer, call transfers you can support, and even FMPWM communication it can also support over there. The next one we have SIM800A module. This comes with dual band communication, GSM and GPRS, and it can work only on two frequencies. One is EGSM 900 megahertz, and other is your 1800 megahertz. These two only it can support. In previous case, we were able to support 850 megahertz, 900 megahertz, 1800 and 1900 megahertz. But here we can work on 2 frequencies only. So at the same time, it can also allow you GPRS based multi-slot SIM insertion. The antenna is available in this form this time, and there are some limited set of pins available. The adapters also you can connect over here. And this was designed to save more power with on-chip capacitors also available that can support your power saving easily. Similarly, with this, further, we have SIM 900A module. Again, another popular module with little bit of advancements. This can also work on 900 and 1800 megahertz. So accordingly, in which countries we are following these standards, accordingly we can connect this particular module. So it depends what kind of project you are building, or maybe some international setup you want to create. So you have to ensure in which areas you will be setting up your system, and whether that frequency matches with your chip or not. So accordingly you can pick up a chip. And also you may have to check the power requirements of this chip, because you will be installing it somewhere in the field environment, and it should work freely over there without any repeated power issues. And of course, signal requirement is also an essential. So although antenna is provided, but it should be placed in a good area where there is no shadow zones, so that it can work freely. Then we come to the Zigbee technology. This is another gateway unit, depending upon how much distance you want to cover. This is one enhancement over Bluetooth you will find. And this is designed with a open, global, and packet-based protocol that allow you to set up your architecture very easily. And it also works on low power wireless network. That was the main reason behind huge popularity of Zigbee networks over the years. And there are plenty of chips that you will find in the Zigbee technology. These are the most commonly used available in the market these days. You can dedicate them to work as a transmitter and receiver module. There are different topologies that we can use for their communication with each other. Some of them can work as masters, some of them can work as slaves, some of them even work as routers to ensure point to point or multi-point communication. So all possibilities are there with these tiny chips. The antenna is integrated. There are limited number of transmit and receive pins that allow you to make connection on the other side with the network. And for the connection also, we have like 3 important devices that you will find in the network commonly. We have one Zigbee coordinator device, Zigbee router device, and Zigbee end device. The router device can be optional. This is generally preferred when you have to use long distance communication, which is not coverable by using independent coordinator and end unit. So intermediate hop when you have to connect, like for instance, you want to complete a network within a building, but your Zigbee module initially can support only ground floor. So you can get a router to set up communication to the next floor, and then on the other floor also, again you can set up multiple routers, multiple coordinators and end device, and then again on the floor above it you can again use a router to send data, and that will be a hop based communication. So if it can cover like a minimum range with the one connection, the routers can further extend it and pass data with better connectivity between different units. These are few general characteristics of your Zigbee module. It offers low data rate, although it works on the short range communication, like from 75 to 100 meters, depending upon what kind of chip you have used. But it offers a low power consumption mode that can allow you easy connectivity over network and allow you to send plenty of information easily. Even the software and hardware configuration is very simple in case of Zigbee. So many people prefer using this to set up a within building network, or to cover up a dedicated range of up to 100 meters without spending more on the Wi-Fi, because Wi-Fi is generally power hungry. So that requires a lot of arrangement for your maybe batteries or for the continuous power supply in that case. But these Zigbees can work on low power easily. And the connectivity for these Zigbee devices we can do in any of these three forms. Star topology for smart energy consumption, and then mesh topology. This allows self-healing, because in mesh topology everything is connected to every other device, and if anyone fails in between, still the communication will go on. And then we have tree topology also, like there will be a central node that works as coordinator, and there will be several routers and end devices like branches of a tree. So accordingly, the network we can set up over there. These are different features of Zigbee that definitely you will find in the specification list, also provided with the data sheets. They allow easy link management, they are low cost solutions, and power management is good, more reliable solution for the hardware setups. These are common advantages of having a Zigbee technology. The next gateway unit you will have in the list is Wi-Fi. I have already shown you 3 different options with the Wi-Fi modules. And there are multiple types of chips available in the market, and each one of them follow a different communication standard. So the distance covered or all these things completely depends on what specifications you have on the chip, and how much power they will require, and what kind of bands they are following. Everything you may have to verify early. Like ESP32 works easily on both 2.4 and 5 gigahertz band, whereas your ESP8266 works only on 2.4 gigahertz band. So these are few mini specification changes you will find with the type of chip you are using. So what kind of network specification you need, accordingly you can choose your chip. These kind of chips I have already shown you, like ESP32 or ESP8266. Few of them I have already shown you, like this one you have seen, and this one also you have seen. From ESP32 also, this one you have seen, and others are also available in the market. Each one of them may have different pin configuration, they may have different frequency ranges to work upon, they may follow different communication protocols, and the power capacities may be also different. The main focus generally goes with the memory capacity of these chips, so that you can store your extensive project codes easily to run multiple chips together. While working on the Wi-Fi, there are few key concepts that come into role play. Especially, you may need SSID and password to protect your Wi-Fi network, so that whenever you are transmitting IoT sensor data, it should be secure enough. Because security is always a challenge in case of IoT. Since we are transmitting everything to the internet, we always need something that is more reliable in terms of security, because that may otherwise hamper our identity, or our personal information may get exposed to the hackers on the other side. So these are the most important things you have with the Wi-Fi that enhances security on the network. Also, in case of Wi-Fi, you work on dedicated IP addresses and MAC addresses. That has to be defined right in the beginning when you are setting up your network, and accordingly the communication will be established. The last option we have in the list of gateways is LoRaWAN, one of the high-end solution you have for the gateways, with higher capacity in terms of area coverage. When you need, like for some industrial setups, or when maybe like your organizational setups you want to cover, some big business houses you want to cover, this LoRaWAN technology is much efficient in that case. The control level, the certification, the standardization is more authentic in this case. This offer a very reliable solution. There are two terminologies that are commonly used. Basically, LoRa is a radio signal that is going to carry your data, and LoRaWAN is the communication protocol that is going to control or define how the data will be transmitted or communicated across the network. So these are the two commonly used keywords in case of this technology. When you go to the market to search these kind of chips, again, they are available from so many vendors. The specifications may vary accordingly, and they may even offer you different kinds of memory capacities and coverage areas. So completely depends on what type of security you need in your network. You can use these LoRaWANs at gateway level, node levels, or network server levels. At different levels, the communication can be controlled in a bidirectional manner, and you may have different types of servers also provided by the LoRa Alliance. They have a dedicated team for this. They have a dedicated company for this that handles everything related to the LoRa communication. So for this again, the learning curve for LoRa is more. If you just try to compare them, the Bluetooth BLE, they are the most easier to understand for any beginner. It doesn't require you to do any specific coding. No much complicated hardware is required. Just simple communication setup you do with transmit receive line, and your data starts going to the cloud directly or to the mobile application, wherever you want to send. In case of Zigbee, again, a step ahead in terms of learning curve I'm talking about. First comes Bluetooth, the most basic one. Then comes Zigbee, little higher than Bluetooth, but still very easy to learn for any beginner. There is a dedicated software that we call XCTU, on which you can do this Zigbee based communication easily. It doesn't take much space on your system, and it can receive your data from the Zigbee network easily, and it can show you whatever you are receiving from the end terminals. Then after this comes your Wi-Fi. The learning curve for that, of course, little greater than your Zigbee. But still, there are plenty of unique modules available in the market, so you can easily set them up, and you can start communicating network data. But yes, the power requirement in case of Wi-Fi will be higher. And then last comes the LoRaWAN. Learning curve is little bit complex in this case, because there are so many network setups that you may have to do. There are some complicated procedures involved behind for the integration of software and hardware, and at multiple levels you may have to follow different protocols. So all those things, although once you learn the process, then you will be able to interface it easily. For these LoRaWAN connections also, you may find different classes for the connectivity: class A, class B, and class C, depending upon what kind of transfers you want to accept in your hardware design. Whether it is a two-way communication, whether you want acknowledgements, whether you need half duplex or full duplex, accordingly the setup you can create. And definitely you can save power also based on the type of connection. So that was all from the hardware that we have in the market. And along with this, before I proceed further, I'll first show you a quick idea about the gateways that I just discussed over here. One is with your Bluetooth gateway, and the one more I have here with me is GSM gateway. Wi-Fi I have already shown you. The LoRaWAN gateway is currently not available right here. That may be on some site right now. So here I have the Bluetooth gateway, and similarly, I'll show you a GSM 900A module. This one. You have seen them in the images also. Exactly same you will find here in my hand. The details about the pin configurations are always written behind. This is a simple Bluetooth module, a simple plug and play type module. You can connect it easily. Similarly, this is your GSM 900 module, and you can see this portion. This is for insertion of a SIM card. I can open up. This is like a SIM card that we used to insert in your old mobile phones, the full size SIM cards that you can insert here, and then you can lock this portion, and it will start capturing signals with this antenna. And remaining other things also you have here, like the regulator section over here. Here you can connect adapter. Again, it works with 12-volt adapter directly you can connect. However, in this case, there is no requirement of additional adapter. Rather, you can connect it with 5-volt and ground directly, and from there it will work directly with your microcontroller. This can send you quickly SMS and calls, etc. Everything it can handle. You have here a buzzer unit also. You can observe this one. This is a buzzer unit. So when a call is coming, you can see this ringing over here, and accordingly, microcontroller, etc. You can use further for the interfacing, and you can send SMS also from here. So all the possibilities we have on this particular chip. Similarly, the other versions also have shown you quickly by using some images over there. The Wi-Fi also I have given you already an idea. Further, I would like to show you a little bit of idea about the software. We have a little bit of time, so we can definitely discuss that. There are two important things that you need to learn as a part of this first session, because both these things will be using further while setting up our project. One is the software that we use to do coding on the Arduino platform, because I'll be using Arduino in the coming sessions. So you may first need to know what software we have for Arduino based coding. And second thing I'll be disclosing here is your cloud platform where we can store data. So again, there are unlimited cloud platforms that support IoT based data storage. But currently, I'll be showing you just one that we'll be using in the coming day lab sessions. So you will see here this one. This is Arduino IDE software. For instance, I can search it like this. This is an application on my system. You can find it from the official website like this. If anyone wants to install, this is your Arduino IDE official website. Just go to the official page of Arduino, and here you will find the software section from where you can download it. If you are using Windows, you can use it from here, Windows 10 or newer versions directly. You can click on this and a software will be downloaded on your system. However, if you are using Linux or Mac OS, accordingly, the versions you can choose from here. It will not take much time to install on your system. Quickly, it will set up its files, and within few seconds, you'll be ready to use your application. So I can search it like this, and here you can see Arduino IDE. If I click on this, it will open up a simple window on my screen. Very easy to use interface, you will see. Let me just open up a blank screen for this. For a quick demonstration, I'll use this blank screen. Now you can observe when I open up a default window on this Arduino IDE software, it comes in this format. This is already written on your screen. By default, it comes like this. And it basically indicates that you have to divide your code into two sections, void setup and void loop. And it is written clearly here that when you have to run anything once, you can put that in the setup section. And when you need some operation repeatedly, you can put that in the loop section. This Arduino IDE platform works on C and C++ coding. So if you know the basics of coding, if you have any time in your life done your C or C++, you can easily do coding for Arduino as well. You can easily connect sensors and actuators on this, and then you can start communication easily. On this platform, you can see there are a few quick options that you can access. The very first thing on the top you can see is select board, because there are different types of microcontrollers that can be accessed on this Arduino IDE platform. I already told you that there are so many versions of Arduino in the market that are listed on here. So for instance, if I click on this, you will find the entire list of boards that are compatible on this Arduino IDE platform. There are like hundreds of boards. You can observe that from Arduino itself, there are plenty of boards. MKR units are there, and you can see these MKR, the most advanced chips that they have designed that can work with integrated GSM, LoRaWAN or Wi-Fi capabilities they have. This Arduino Mega I have already shown you in the hardware also. Then you have Arduino Micro, Arduino Mini, Arduino Nano, Arduino NG. There are different versions of this also. Then similarly, you can search for Uno. So that will be right here. This Uno, your basic module. We can connect it and it will select this Arduino Uno. Whenever you connect a hardware on your this Arduino IDE platform, you may first need to choose the type of hardware on this software. This is very important to understand if you're doing it for the first time, because otherwise you may spend so much time to understanding the software interface only. That is why I'm displaying these things over here. First, you have to select your type of hardware. So if it is Arduino, you know, in the same process, you have to choose that. The second thing you have to choose is port. You can see here it is written select board and port. Two things are important. So port you can select from this section. You can see here. Currently it says no ports discovered because I have not connected any Arduino or any kind of microcontroller on the USB terminal right now. If I connect any type of Arduino, for instance, I'm inserting one Arduino cable into the USB here, and you can see COM8 serial port, it started showing immediately. Now I can select this one along with Uno from here, and okay. And then you can see this gets darker, and now we can see the connection also over here. Arduino Uno on COM8. So depending upon which USB are using on your system, accordingly, these selections you have to do. This is the very first thing you need to do while opening your software, and then start coding further. Other than this, as a beginner, there are few interesting things that you may need to understand. In the file section, you will always find some by default examples. Whenever you install this software for the first time, it comes with so many examples. As a beginner, you can start with them anytime. For instance, we have a blink program that allows you to check the blinking operation on your Arduino directly. So there is a blink LED available, and accordingly, it will start showing you a quick operation of that. Similarly, you have digital communication programs, analog communication programs, few by default sensors are also available, USB interface, and plenty of other things. As a beginner, you can start learning from here. And then as you advance your work, you will see examples from custom libraries here. This will not be available in your case by default, because this comes as you start working on new libraries other than default. For instance, in my case, I have installed so many libraries here in the list because I keep on working on different modules. So they are listed over here. So these libraries we add as per our interest. And there are few ways to add libraries also that we will learn further in coming sessions. So new libraries also you can add as per your requirement. Depending upon what chips you are introducing into your code, accordingly you can insert new libraries over here. Similarly, in order to look at the output on your screen, for instance, what you are reading from your sensor, if you want to display that on your screen, we have a serial monitor for that on the top of this corner. Here you can see serial monitor. If I click on this, it will open up a serial monitor here. And whatever code is already running on this software, on this Arduino chip, that will be displayed immediately on the screen. Second thing is your serial plotter. So in case if you want to plot certain type of data, maybe you are getting some voltage or current measurement from somewhere and you want to plot that. So for that, you can use plotter. And accordingly, as the sensor is connected, those lines will be plotted here. The waveform will be created here. So again, you can get data from the analog as well as digital channels, and that you can display over here, either in the form of values or in the form of waveforms. Both options are there. Similarly, you have here these sections you can find. They are, the first one is for accessing different folders where you have stored your different types of projects. The second one is for your board manager. This is very important again, because there are so many types of boards available. Like for instance, you can even set up code for your ESP chip using this Arduino IDE software. And for this, you first need the board for ESP. Like if I search here for ESP, it should show me the ESP board. See this one? Because I have already installed it, so I didn't get the install option, rather an update option. In case if you have not installed anything, it will show it like this, install. So whenever a new board you want to introduce, like this one also I have already, because I keep on using them. So I have them already in the list. The ones that I have not used, they will come like this install. The ones that I'm using is comes like this, remove or update. So these are the additional boards that we want to interface with the system over here. Similarly, the third one, this is for the libraries. As I told you that sometimes we need to insert libraries also to the system. Like for instance, one sensor I have shown you, DHT sensor. The DHT sensor works with libraries. Again, you have to check specifications of your hardware, that how it works. So if it works with hardware, with library, we will search for the library, the compatible one, And then that list you will find right here. Like, see, DHT11 library. I have already installed this because I keep on working on DHT sensor. So this is already here. And they are available from so many different vendors. So depending upon which one is compatible with your sensor, from which vendor you have purchased your sensor, accordingly the library you may need. There are few sensors that work without any library. So accordingly, you can use them directly. We will learn that in coming sessions, that how we interface different sensors into the network. So this was your quick interface idea with the software, in which we'll be doing coding tomorrow. Similarly, to send data to the cloud platform, I'll just take 2-3 minutes with this. So this is for the cloud platform. ThingSpeak will be using. One of the freely available solution. As a beginner, you can use this. They do not charge you up to 4 channels. You can see, you can log in on this. You can create a login by using your email ID on this ThingSpeak platform. This is by default integrated with MATLAB. Many of you might have already used MATLAB platform. So when you gather data from IoT projects, you can analyze them directly on the MATLAB on the same platform. This is online integration. And in order to log in also, it will log in through Maths Work, that is powered by, that powers your MATLAB platform. So on this, once you create a login, then it allows you to create a different channels. You can see in the My Channel section, since I have here 4 channels in which I keep on monitoring things and I keep on storing them. So all the sensor data, for instance, smart healthcare project here, the data from like ECG, GSR, heart rate, or body temperature, these kind of things I have monitored sometime. So those readings I can see over here. This was just like a testing project, so you will not see very frequent readings, but you can see, observe the readings over here. This is how we collect data on the cloud. So you can set up, as a free user on ThingSpeak, you can set up 4 channels, and each channel can measure 8 different parameters. You can see currently here you can see 7 are enabled, but generally we have 8 different fields that you can use. That clearly means that you can, as total, you can save 4 into 8 parameters, 32 parameters in all you can measure on your single account. So that is a big enough to start a beginner level project. Depending upon if 5-10 sensors you are using and they are measuring multiple parameters, you can store them easily on the cloud here. And whatever you are saving here on the cloud, that you can import, export as a CSV file directly. You can observe here, export, download directly as a CSV file. So this will come as a CSV file. So whether it is like months of data or years of data, that can be installed, downloaded easily in the CSV format, and then you can do processing with that data. So all these terminologies further will be using in our project tomorrow and day after tomorrow, and then you will get friendly with this environment. Currently, I have just given you a quick idea about what are the possibilities with this IoT setup as a beginner, what you can start with, and how you can deal with different terminologies over here.